Good morning, everyone. Today we are going to see syntax analysis in compiler design unit 2. So syntax analysis is a second phase of our compiler design, right? So this process in which the given input string is checked for the confirmation of rules and structure of the formal grammar. So it analyzes the syntactical structure and checks if the given input is in the correct syntax of the programming language or not. It is a syntactical structure of the programming language. It recognizes the syntactic structure of the programming language and transforms a string of tokens into a tree of tokens and syntactic categories. Parser is the program that performs syntax analysis. So in syntax analysis, what are all the topics covered? Introduction to parsers and syntax trees, what is CFG, and push down automata, and parsing techniques, that is top down and bottom up parsing techniques. So what is a parser? It is nothing but a syntax analyzer, right? Syntax analyzer in compiler design process comes after the lexical analyzer. So after the scanner, this is our second phase of our compiler design. It is also known as the parse tree or a syntax tree. So the parse tree is developed with the help of predefined grammar of the language. The syntax analyzer also checks whether a given program fulfills the rules implied by a context-free grammar. If it is satisfies the parser, then it creates the parse tree of the source program. Otherwise, it will display the error messages to the error handler. So all the phases are connected to the symbol table, which is managed all the characters, group of extra symbols or special characters, which are all managed by a symbol table manager. So what is syntax tree? It is a nothing but a parse tree which represents the syntactical structure of tokens in a program which is defined by the grammar of the language. So this is an example for our syntax tree. So what is context-free grammar? A context-free grammar, it is a set of recursive rules used to generate parser patterns of strings. Okay, so a set, it is a left recursive grammar that has at least one production of the type. So these rules in a context-free grammar are mainly recursive. So a syntax analyzer checks that the specific program satisfies all the rules of context-free grammar or not. If it doesn't meet these rules, syntax analyzer may create a parse tree for the program. So in context-free grammar, we have a set of terminals, that is basic symbols, which can be formed from the strings. A set of non-terminals, which are syntactical categories, each of which denotes a set of strings, and a set of productions. So these are the rules specifying how the terminals and non-terminals can be combined to form a strings. So we have only one star symbol, which is distinguished non-terminal that denotes the whole languages. So this is an example for CFG. So terminals may be the identifiers or special operators. So non-terminals, which are expression or capital symbols or operators. So production is written as like this. So this is also called a grammar of the language. So expression implies expression, right? This is the left hand side and this is the right hand side of the production. So we have start symbol here, expression. So identifiers is written in the program as, so in curly braces, that is identifiers. So place is written as like this. So all the special characters are written in the curly braces. So we have a derivation system in the syntax analysis. So how do we derive the productions? Okay, left hand side, how we are going to expand the non-terminals, and right side, how we are solving our productions, we are going to see. So what is derivation now? A derivation step is an application of a production as a rewriting rule, namely replacing a non-terminal in the string by one of its right-hand sides, that is n implies alpha. So starting symbol with the, we are starting with the start symbol. A sequence of derivation steps is also called a derivation. So we'll see the examples for this. So grammar of the language looks like, so we can write expression implies expression. This is called a right side of the grammar. This is also left side of the grammar. So we have to derive from this grammar. So we have two types of derivations here, leftmost derivation and the rightmost derivation. So if there are more than one non-terminal in the string, so many choices are possible. So first if we want to do leftmost derivation, we have to derive leftmost non-terminal will be expanded in the right hand side. Okay, so in rightmost derivation, a rightmost derivation is always chooses the right hand side non-terminal will be expanded. So this is an example for leftmost derivation. See here, take one production and expand only leftmost non-terminal. So here in rightmost non-derivation, we are expanding rightmost non-terminal. Okay. So from left to right, we are going to derive our productions from right hand direction. So from right to left, we are going to derive our production. So what is the parse tree? It is the output of syntax analysis, right? So a parse tree, it is a graphical representation for a derivation that filters out the order of choosing non-terminals for rewriting. So many derivations, it may correspond to the same parse tree, but every parse tree has associated with it a unique leftmost and a unique rightmost derivation. So this is also an example for parse tree, how we are deriving the rightmost tree. Okay. So here expression right side, we are going to derive the parse tree. So what is ambiguous grammar in the syntax analysis? Ambiguity means more than one parse tree, right? So a grammar which is having more than one parse tree. A grammar is ambiguous if it can be derived a string with two different parse trees. If we use a syntax structure of a parse tree to interpret the meaning of the string, then the two parse trees have different meaning. So since compilers do use parse trees to derive meaning, so we would prefer to have unambiguous grammar. So we are likely to prefer only unambiguous grammars only. Clear? So this is an example for one each input string. Okay, so for this idea, for this expression, we have two parse trees here. So this grammar is said to be ambiguous because we have two parse trees here. Consider this example. Take the expression. So we have here plus operator. We are expanding here only right hand side of the production, right? So this is called rightmost derivation. So here in this, we are expanding only left hand side of the tree, right? So this is called leftmost derivation. So for this grammar, we have two parse trees. So this is called ambiguous grammar. A grammar is said to be ambiguous if it has more than one parse tree. So compare the ambiguous grammar and unambiguous grammar here. So ambiguous grammar is having more than one parse tree, and whereas in unambiguous grammar we have only one parse tree. Okay, not every ambiguous grammar can be transformed to an ambiguous one. So we can see this push down automata in finite automata session. So these are the examples for parse trees. So what we have types of parsing, syntax analyzer follows the production rules which is defined by means of context-free grammar. The way the production rules are implemented, that is derivation, divides parsing into two types. So we have two types of parsing techniques, that is bottom-up parsing and the top-down parsing. So we are going to see this top-down parsing and bottom-up parsing in the next session. Thank you for listening.